My name is Anna-Kaisa Kultima, and this is Games Now. Games Now is an open lecture series run by Aalto University on the hot topics of game industry. If you have missed any of our lectures, make sure that you follow us on our social media channels. We also have a Discord chat if you want to continue with the topics there. For the past 15 years, a lot has happened in games. And such an extensive perspective creates a perfect platform for exploring the futures. Today, we have a special treat of that sort. Anna Kipnis will share her lessons learned while working as a gameplay programmer at Double Fine. Welcome to the stage, Anna Kipnis.
Thank you. Just want to make sure my mic is on. Is it on? Can you guys hear me? No. Oh, okay, here we go. Hi guys, my name is Anna Kipnis, and I did gameplay programming for about 15 years, 15 and a half. So I'll be speaking to you today about some of the gameplay challenges that we had in Double Fine games with the hope that it will help you avoid them in your own work. So I started my career in game development with Double Fine back in November of 2002. And these are some of the games that I've contributed to as a programmer and a designer over the years. Have you guys played any of these games? Okay, cool. Well, don't worry if you haven't, because I'll show you a couple of trailers later. So Double Fine tries to be very open and honest about the game development process, and they have had a really talented in-house documentary crew, 2-player productions, filming various documentaries about the projects going on at the studio since about 2012, which is when Broken Age kind of began. And all this goes to say is that if you want to see some of what I'll be talking about in action, you can actually check out the documentaries. They're available for free on YouTube. So before getting into concrete examples, I'd like to start off by coming up with some kind of description for the kind of work that is expected of a gameplay programmer. So the most common job description in our industry is that it's someone who works on what are called the 3 C's, that is camera, characters, and controls. Now this goes a long way to narrow it down, but I'm sure all of us who have done this work have found that it's not just limited to these things. So for instance, when I was working on my first game at Double Fine, every single level was a collaboration between a world builder, so it's like an environment artist basically, and the gameplay programmer. So in other words, there were no level designers. The world builder was responsible for the physical level design, such as the layout, the action path, the camera geometry, the 3D art, and the gameplay programmer did all of the level-specific logic, mechanics, any character behaviors and interactions, implemented all the dialogue, hooked up puzzles, made tools that environment artists might have needed, and so on. So in other words, the work that was traditionally the domain of a level designer was split between a gameplay programmer and the world builder. The creative director on Psychonauts, Tim Schafer, allowed us a lot of creative control, which meant that like these level strike teams that we had, we got to design many of the puzzles, player mechanics, character behaviors. So as gameplay programmers, we had to develop a really strong instinct for interaction design and the craftsmanship that you needed to have to polish things to really wow the player. There have also been times when I've just done work that is traditionally the domain of system programmers, so like adding features to a cutscene editor, adding new sound engine features for our audio team, like writing pipeline tools to create, implementing dialogue, creating and pushing builds, and so on. Now, around 2005, when we were ramping up staff to work on Brutal Legend, this was the job description for gameplay programmers that we posted. So the gameplay programmer will assist in the creation of compelling entertainment experiences across all levels of the game by programming behaviors for all interactive game elements. So later on, I think around 2016, when they were hiring for Psychonauts, the new description acquired a substantial amount of detail, but here it is in a more readable form. But the original copy said, contributing to a wide variety of gameplay systems, such as player controls, weapons, and agent programming, as well as integrating assets from audio, art, and effects into those systems. Strong software development skills, a passion for creating player experiences, and an instinctual understanding of design are a must. Candidates should be fluent in C++, have experience with dynamic programming languages like Lua, Python, or C#, have a solid understanding of 3D math, possess good problem-solving skills and debugging skills. They're able to develop creative solutions to difficult problems, and possess a passion for adding the extra polish that truly sets games apart. So not every company defines a gameplay programmer like this, of course, but some of the best gameplay programmers we've hired, including those who have spent their careers at other companies, are particularly excellent at these things. So I want to share with you some gameplay war stories over my years at Double Fine. And to help you along, here is the engine timeline at Double Fine. So they've shipped games on 3 engines. The first one was Lipo, which is the Psychonauts engine. It's an in-house engine written from scratch at Double Fine. Buddha was written for Brutal Legend starting in 2005 and was used for every 3D game shipped until 2016. Between 2009 and 2016, Double Fine shipped at least 1 game per year, which is a testament to Buddha's capabilities. Starting in 2011, Double Fine also began using Moai, that's M-O-A-I, as our 2D engine. So Moai, it's an open source engine that Double Fine adapted and then modified extensively in some cases based on project needs. So for instance, a substantial modification to Moai became the Reds engine that was used for Broken Age and Dear Leader. If you're wondering where these crazy engine names came from, the names are from San Francisco Chinatown bars. So the Psychonauts code name was Lipo because that's the bar where one of the first Psychonauts team meetings took place. And that's actually how the whole tradition got started. Brutal Legend was codenamed Buddha after a bar across the street from Lipo, and Broken Age was Reds, and so on. Double Fine gives a project bar code name so that the teams can come up with a way better suited name later. So because what happens early on, you give a name and then everyone just gets attached to it. So even though you might not have come up with a good one, that's just what everyone calls it. So we started doing this bar thing because we knew that we would have to come up with a decent name at the end. So all of these engines core was written in C++, and actually that's the case for all of the engines in the industry. They're all in C++. Much of the gameplay in these engines was written in Lua, which is a dynamic scripting language. It's worth noting that Double Fine has recently retired its engines and has switched over to Unreal 4 for these games. Which brings me to this important topic. Back in 2000, when work on Psychonauts first began, if you wanted to make a game, you had to write your own engine. These days, if you want to make a game, you can still write your own engine, but your best bet is actually to just use an existing one. So as a gameplay programmer, working alone or with a small team, that is by far your best option. We retired our engines mainly because we didn't have large enough tools teams to continue updating them for modern platforms, or support the latest state-of-the-art graphical features, and especially the artist tools that accompany them. The companies that make these engines, they have massive tools team working on improvements all the time, and it's just in your best interest to take advantage of their efforts. It's really hard to keep up with things otherwise. So how do you pick an engine? Well, first and foremost, it should be about what your game needs. If you're making a text adventure game, you don't need to use Unreal 4. That's overkill, and the engine will just get in your way. So maybe use Twine instead. If you're making a AAA first-person shooter with lots of bipeds, on the other hand, Unreal 4 is definitely something to look into. And then Unity is just a great overall engine. So if you're not quite sure what your game will have, maybe start there. If you're making games with young kids on your team, or your team is just not technical, use a simpler engine like GameMaker, Stencil, Twine. If your team is very technical, your options open up to advanced engines. Unreal 4 has really excellent art tools, and they allow your non-programmer staff to prototype very quickly with visual scripting. They also give you all the source for free. This is a huge deal. However, if your team is mostly programmers and you don't care about graphical fidelity as much, Unity is a better bet because you have dynamic scripting languages like C# available to you. Visual programming systems like Unreal 4's blueprints, they allow you to write code without having to learn a programming language. But they do have kind of surprising downsides, and I just want to warn you about some of those. Blueprints are all binary files, so only one person can work on a blueprint at a time. This also means that it's unfortunately not possible to merge code. There is blueprint code diffing, which is really nice, but you can only diff files from within the Unreal editor, and it's only visual diffing. This is a problem if you're used to being able to just read code changes from email or something. You will at least have this available for you with your C++ files, though. Code readability tends not to be as good as it is with text, even when you try your best to comment and organize. There's also, it's just much slower to create code with visual UI compared to typing, and it can be really tough to refactor, especially since there's no find and replace for blueprints. Still, there's visualization for behavior trees, and to be honest, the more you use blueprints, the faster you get with them. Plus, as I mentioned, you get free C++ source code with Unreal. So if you prefer working with code, you could do a lot of your gameplay right in C++. So yeah, you'll be able to take advantage of some incredibly powerful features in there if you take the time. So back to the pick your engine list. The other important consideration is, of course, what platforms you need to be shipping for. So if you're shipping for every platform, or doing a VR game, your two best options are Unity and Unreal 4. If you're making a mobile game, you can use a wider variety of engines and frameworks, but try to keep your options open for brand new platforms because it's really hard to make money on just one platform. Speaking of money, you should of course consider cost, and aside from the basic cost of licensing the engines, you might want to think about what features and tools your game will need, and whether you could save time by just visiting the marketplace and stuff instead of writing it yourself. As a gameplay programmer, you might have additional preferences like the ease of working with an engine. So here I want to talk about Lua because I really love Lua. And it's the dynamic scripting languages are just a pleasure to work with. So every single engine we built at Double Fine used Lua for its gameplay code. And good languages like Lua get out of your way and just kind of let you do what you need to quickly. They align more closely with the idea that you should be representing, they should be representing and thinking of your game content as data and your language as your means of processing the data. So Lua is very simple to read and write and allows easy transformations of data thanks to its incredibly elegant table data structure, and that's what you see on the screen there. What you're seeing is actually a transformation from an array to a hash table or a map, and then from a string to a table. You have to account for this change in the code, but it's actually very easy to write and modify code that processes this data, and I'll show you an example of this in the next slide. So because Lua is dynamically typed, it doesn't waste your time with explicit declarations or casts when you're just prototyping. So what I mean by Lua being dynamically typed is that its type checking is performed at runtime, not at compile time. So values have types, but not variables. So we saw how useful this was in the previous slide with table transformations, but this slide shows an example of Lua's power, but also its downsides. So what you're seeing there is a table and then a function that processes that table. And you can do really cool stuff, like you can check the type of the thing that's been passed in. But, sorry, this typing's kind of slow here. I should have sped it up. But I'll show you in a second kind of what happens. You can change the type of that table. So first, let's call it. So tables are passed by reference. But we can completely see the table had a function inside of it, but you can just override it at will. And Lua doesn't mind. Like, you can really get into some trouble with a dynamically typed language. The greatest setback is that many errors you've made will show themselves at runtime rather than at compile time. And it also means that your IDE will have a really hard time knowing what a particular variable is because it has no type signature. The code also tends to run slower because optimizations can't be made on type signatures. And the advantages of a dynamically typed language for gameplay programming are too many for us to ignore. So to get around some of these difficulties, what we did at Double Fine was just have like really simple naming conventions that just showed the intended usage, just these three actually. And this lets other coworkers or our future selves quickly understand what the code is trying to do and just catch obvious errors when you're skimming the code. So, for example, if you see something with a B prefix being assigned to a string, you know something has gone wrong because the intent was to use it as a Boolean value. So, same with tables and strings. So it turns out in practice that we only really needed 3 of these, no more. That was simple enough. So we also had to run a Lua linter to find accidental variable misspellings, which tend to show up as global variables. We avoid doing data process over large sets of data in Lua because that's very, very slow. So those get pushed into C++, and same with math libraries. And we profile our gameplay code often and push anything that runs slowly into C++. So LuaJIT has actually kind of fixed a lot of these problems. For those of you anxious about the lack of compiling in Lua, C# is another great dynamic language. It's easily extendable, has static typing, has fantastic data structures. Maybe not quite as simple as Lua's and elegant, but it gets out of your way so you can kind of focus on the problem in hand. And it typically has fantastic tooltips, so it kind of feels like just the code like writes itself. Another important consideration, the engine should help you make your game quickly. Like, you will need to iterate a lot on your game, and there are tools you can use, like dynamic scripting languages, custom debug commands, and so on, that make this a lot faster and easier. So first thing being, it has to be very quick. It should not take you ages to compile your game every time you have to make a small change. So our job as gameplay programmers is to get a taste of what the game feels like for the particular thing we're working on, like to form that impression of it and just hold it onto it as long as we can so that you can compare it to this change you just made. So the longer you wait between changes, the memory of that last impression just completely fades from your mind. So a great way to solve this is, where possible, represent everything you're trying to tune with data and use live editing if your engine supports it. You can also hook up a MIDI controller to various values in your game to help you tune it. I don't know if this animates, maybe not. Oh yeah, it does. So this is Bennett Foding tuning his physics system in the game, actually. A colleague of mine has written a free library that makes it easy to hook up a MIDI controller, and they're only about 40 to 50 bucks. They're like really great for graphics programmers too. Speedy iteration is also something that comes with being really familiar with the engine. So we learned the importance of that when working on our second game at Double Fine. So in 2008, Tim, we had been working on Brutal Legend for about 3 years at this point, and we just, no matter how much you love the game you're working on, a creative fatigue will set in, and it did. So we decided to do a company-wide game jam where we kind of forgot everything, about Brutal Legend, which is Amnesia, and for 2 weeks, fortnight. And we had been writing Buddha engine from scratch specifically for Brutal Legend, and many of us kind of fantasize how great it would be just for any type of game. But we actually had little hope that anything at all resembling a game could be made in 2 weeks, right? Because at the time, our production schedules were Psychonauts, 4 to 5 years. Brutal Legend, we'd been working on it for 3. It's just 2 weeks, are you insane? But it turned out that it totally worked, and we had gotten very quick at creating things with Buddha. Dear Leader Amnesia Fortnite prototype was similarly made with the Reds engine, which was used for Broken Age. So yeah, using an engine you know well cuts down on the time you spend struggling with the technology. By the way, if you're interested in seeing Amnesia Fortnite, you remember that you can check out the documentaries on YouTube. So to go back to 2008, after Brutal Legend shipped, I joined the Costume Quest team as lead gameplay programmer. And Costume Quest was originally an Amnesia Fortnite prototype that we were able to pitch successfully to publishers, in large part because we had something playable to show them, which was the prototype we made for Amnesia Fortnite. normally at the time when you went to pitch to a publisher, you might have like, a few concepts and like maybe designs. You would just show them like pretty pictures and stuff, but it was really rare for publishers to see a working prototype. So like this contributed to like, this is the reason why we were able to stay alive as a company, because we started just making a bunch of games simultaneously. So I just want to show you this early prototype.
Trick or wait, this is my house.
Sorry kid, but this isn't a costume charity. Come back when you have at least 75 pieces of candy to trade.
The first rule of Halloween is, no costume, no candy. Come prepared next time. Trick or treat. Nice costume, kid. Now take some of this candy before I eat it all myself. Trick or treat.
That's a rat from Psychonauts.
Let me think. You get a trick. Oh,
Gross. Anyway, and I also just kind of want to show you the trailer of the final game so you can see how many elements survived all the way through the project from that prototype.
Every year on Halloween, grabbing candy left and right, ghosts and witches can be seen trick-or-treating through the night. This year it's a different deal. Someone new has come to town. Now the monsters are all real, and we have to take them down. There's a witch who thinks she might steal our candy for the dawn. We've got costumes built to fight. Now the battle's really on. From the imagination of Double Fine Productions, take an amazing adventure on Halloween night, following the quest of a brother and sister torn apart. Explore, collect, and develop skills and abilities to help you in battle. Transform from humble trick-or-treaters into heroic warriors in this instant classic for kids and grown-ups alike. Costume Quest, coming this fall to Xbox Live Arcade and PlayStation Network.
All right, so Costume Quest had to ship in 8 months. This was brand new and crazy for me. To put it into perspective, both Psychonauts and Brutal Legend took about 5 years to complete, and both had custom engines built especially to support the systems they needed. And here Costume Quest was an RPG and a genre we'd never done before, a Double Fine, with a different dialogue system compared to all of those games. So luckily we didn't have to write an engine from scratch. We could use Buddha engine that we made for Brutal. But I wanted to show you a couple of systems we also leveraged to save a lot of time in Costume Quest. The Buddha engine was a component-based architecture, and this is probably familiar territory to all of you who've used Unity. The massive advantage of this kind of architecture, of course, is that you can pick and choose a la carte, like what your entities are made up of. And the entity itself is just a vessel for holding all of those components. Now, this was a brand new technology in 2005. Like, this was not widely accepted in the industry. What was widely accepted was this actor, this is deep hierarchy model. It's deep class hierarchy. So Unreal Engine still uses this, but so why did we switch? Well, there are a lot of there are a lot of disadvantages to deep class hierarchy for constructing game entities that honestly make it inferior in every way to components. First of all, since a lot of the features and member variables get stuck into the parent root to support more complex objects, simple objects end up inheriting a bunch more functionality than they will ever need. So there might even be extraneous method calls and stuff. The opposite of that situation is where your leaf objects, typically the player have a lot of functionality in them and they don't share it with anyone. What ends up happening is the code gets copy-pasted rather than reused. Or maybe the functionality gets pushed into the base class, so like everything kind of inherits it, right? So for example, like where do you stick moving platform? Like do we make all platforms movable? Do we copy paste code from platform into moving platform and parent it to movable object? Or parent it to platform and copy paste from movable into, like none of these are ideal solutions in any case. So structuring the code properly requires like a lot of assumptions about what your game will be from the very beginning, and it makes it like very, very cumbersome to change direction during iteration. And you may end up refactoring very frequently, which tends to be like super slow and error prone. And last but not least, touching the base class object may break every object in the game, even objects completely sequestered from one another, and this happened to us constantly on Psychonauts. Components, they alleviate these problems by allowing you to customize game objects more gradually, or more granularly, sorry. You also generally don't have a lot of inheritance depth with components. And if you break the functionality up well, you'll be writing a lot more reusable code. So you can reuse all the components from the last game you made and just modify the ones that your game needs. And this helped us a lot in Costume Quest. All the other games we made with the Buddha engine over the years also benefited from this, and it's what allowed Double Fine to actually ship so many games without growing the team size. So like there was a question about this actually earlier, but the team sizes for Psychonauts was the entire studio. Team size for Buddha Legend was the entire studio plus a bunch of people that were hired. And then the studio kind of ran in this way where there were about 4 to 6 projects going on at the same time. And it was just that size of Buddha Legend that like got split up into smaller teams. I think the teams were, by the way, like about between 10 and 20 people, and they would like ramp up or ramp down as the production continued. So we made a lot of really solid decisions in my time at Double Fine, but I want to talk about some of the mistakes that I learned from, and I hope that you can learn from them too, so you can avoid them. So one of the best examples of what not to do happened during Psychonauts. When I first started working on the game, we were only beginning to implement dynamic dialogue. And we followed an unfortunate convention that dated back to graphic adventure games at LucasArts, where dialogue was put directly into the code in English. By the way, the game was going to ship with 5 languages. The convention was using double quotes to indicate a dialogue line, and then single quotes for any other strings necessary for code, which is very flimsy. So the hope was presumably that a string processor would go through all the strings in the code and somehow map them all to the voice lines, but there was no official way of tracking lines at this time. Now, think about that for a second. When Psychonauts shipped, there were 8,304 voice lines and 1,596 text-only lines. And what you're seeing there is the list of all the lines in the game for our internal tracking tool that, by the way, did not exist at the time and exists now entirely because of this terrible lesson we learned. So what could go wrong when you have 10,000 lines just hanging out directly in code, all in English, and your game has to ship for at least 5 languages? Right? Okay, so for one thing, since there's no unique identifier for a line, if the writer changes their mind about how they want to phrase something, or if they decide to cut lines or reorder them, all of this has to happen directly in the code and normally not by the writer. So the writer has to communicate this change to the programmer, maybe with an email or a chat message, maybe walking all the way up to them like a goddamn animal, but there's a lot of room for error. And the result was that the writer's script often did not match what was in the game. Can you think of some things that could go wrong here? Maybe the programmer forgot to update the line, right? They have a lot of work, a lot of other features to work on, they just forgot. Maybe the programmer didn't get it quite right, maybe there's a miscommunication with the writer, or there was a typo or something like that. Especially if the communication happened over chat or email, sometimes what would happen is that the writer might decide on a line with the programmer and then forget to add it to the original script. So now there were changes in the game that were actually not in the original script, which is it's a more rare situation, but it happened. Maybe the writer changed their own script but forgot to tell the programmer about it. Maybe the programmer wasn't at their desk or something like that, right? Maybe the writer went into the code to change it themselves and introduced all kinds of syntax errors. So we hit every one of these problems on Psychonauts. There are also like kind of more subtle problems that could be introduced when the lines are like, thought of as living in the code. So for instance, let's say you wanted to have icons mixed with the text that represented buttons on a controller. So instead of using a convention within the line itself to indicate that, like, a dynamic placement might needs to take place at runtime, that's like that less terrible, still bad example. Because like as an English speaker, you're really tempted to make all kinds of assumptions about other languages. But the order really matters in some languages, and it's just different. But a programmer might not be thinking about that at the time and do like the super terrible thing right there in the first line. And also a string processor looking for the double quotes will totally get tripped up by this, right? So localization was a really big issue because words get moved around, right? And a programmer might be unaware of this and yes, completely screw over some languages. Now the distinction between the game and the writer soon became a much bigger deal when the lines were scheduled by for recording by professional actors. So the script the actors got often did not match the lines that were actually in the game. But even when they did, a more subtle thing could happen, which is that sometimes an actor would read a line very differently than what was strictly in text. And sometimes what the actor said did not match the text at all. So sometimes you actually want the actor to improvise because you know a line is going to repeat a bunch, so you want like kind of a different sound. So I'm going to show you this video. This is Pendleton Ward you might know him from, he's the creator of Adventure Time. Do you guys know who that is? Yeah? Okay. So here, I'll play the video.
Now just get over here, grab my underwear and unhook it from this branch! You want me to make up things?
Oh yeah,
Sure, if you want to.
My underwear, it's on the branch. Can you unhook it, please? Unhook my underwear? Get over here and unhook me from the branch! My underwear's on the branch!
Who wrote these lines?
You just come down
writing
here
them all right
and
now.
torture me? Oh yeah! Cut my underwear! Cut it! Oh yeah! Cut it! Cut my underwear! Keep cutting it!
So to integrate the new lines, you had to once again have a programmer copy edit the line in the code and possibly screw it up or forget. And the amount of requests for small tweaks for gameplay programmers got a little crazy, needless to say, and they were not the best use of a programmer's time. So sometimes the actor would read the same line a number of times, and the director, like Tim, would like all of them. So what do you do in that case? Like now the text of the line was the same, so how could you deal with, like if the English was exact in the code, like how are you going to make a difference from that? So yes, this was a big problem. And since there was no official way to track any of these lines, there was no easy way for us to even verify that every single voice line in the game was recorded. And the voice director we contracted, she had her own method. You actually saw her in the video. That's Chris Brown. She had her own awesome method for tracking the lines, and it was far more organized than anything we had at the time. So sometimes the line would go missing, and then it involved listening to all the voice lines to verify that it indeed was missing. And this is all incredibly time-consuming. So dialogue requires very, very careful organization, even when it's not going to be voiced. So consider all those text-only tutorial lines and the fact that they had to be translated into other languages, and they might be changing throughout the development as we change controls and so on. It took us about a month or two of 90-hour weeks and 0 days off for the gameplay programmers and the audio producers to actually fix all of this. It's an incredible amount of work. So basically, each line got a unique identifier, and we used only that ID in the code. That way, what would happen is that you have this one place where everything is tracked, and when things changed in there, you would export into a game resource, and that's the resource that had the codes, and it would match to the dialogue. You can actually find out a lot about this from my dialogue talk. I'll mention it later. Anyway, we were extremely lucky to run into all of these problems before work on localization actually began. So had we not cleaned up our act before that, it would have been an absolute nightmare. So lesson learned, entering dialogue lines or tutorial text directly in the plain code is a terrible, terrible idea. So yeah, here's the talk. Check it out if you want to see what like the full solution for this is. I'll mention another hard lesson learned during Psychonauts, and that is until I got my first job at Double Fine, I had never worked on a game that required building levels. And that was not unique to me. Many of the video game veterans at Double Fine came from LucasArts, and they had a graphics adventure background where level design for physical levels and challenges, it did not figure largely into production. So in general, 3D environments were really new at this time. This is 2002, right? So like, when did Mario 64 come out? Like, a couple of years before maybe. So the design process was not widely agreed upon, or like there were no schools, I think, who offered game programmers. So we just had to kind of figure it out on our own. And we did not yet know how important it was to first create a gray box of the level and iterate on it until we were absolutely sure it was fun to play before you add the beautiful art to it. So as a result, a lot of the environments seen in this 2002 trailer had to be rebuilt. And this was long after the artists had already begun work on the levels. This is a classic rookie mistake, and one that I'm sure none of you would ever make, because you know all about this now, but we didn't at the time. So there might be some very similar kind of like analogous situations in your work. So when you're coming across the same mistake over and over again and you're having to completely redo something, think about what process you're following, because there might be a problem there. So what we do now is we get a level into a playable state when it's like to a state where it's fun, and then we have our concept artists do drawovers as a guide for the look we'd like in the final art, and then only then do you start modeling. So here's some other lessons we learned the hard way about creating shippable levels. You need to start with a level that is representative of your game. And what I mean is a level that features the length and type of gameplay experience that most of your game will have. So if you're building an open world game with a section of the game, start with a section of the game that is like, representative, or like a particular mission that you think is going to be common. So the idea is to really understand what it takes to build your entire game. So like what assets you'll find yourself building the most often, like what infrastructure you'll need for each level and the overall game, and what disciplines are going to be important to have on your team, right? So it will allow you to schedule your production better with fewer surprises and like much less crunch going forward. And one piece of good news is that the very first level you build will always take you a lot longer than the subsequent ones if you do this right. You'll likely have some struggles with this initial effort, but having gone through the process, you'll feel better about the risks, and you're in a better position to mitigate them. So in practice, this is easier said than done. So for example, what level would you start working on first in Psychonauts, for those of you who've played it? Any ideas? No? Okay. So the problem with Psychonauts is that you had to go into all of these mental worlds, and the gameplay is substantially different in each and every one of them. When we started working on the game, we didn't know how much each would differ, because it seemed like nothing was safe. Like even Raz's movement set was changed in that Lungfishopolis level. The story also took place in the real world of the camp and the asylum that you travel to later in the game. And in these hub levels, the gameplay and the player's moveset would be a lot more consistent. So the safest level for us to start from turned out to be the real world hub level. Now that is not the one we first started from, but that would have been a great one. We knew from the design that these would be the main areas, and they actually provided the glue to keep the game cohesive. So like, you could have the characters in there and you could come up and enter the worlds from there. In fact, sometime halfway through development, what we did was we actually set up empty areas with just the character there, so you could like come up and interact with them, and you can just enter their levels like that. Since the brain levels were going to be substantially different, creating a brain level with a particularly strange gameplay would be important to prove out, like, right after that vanilla hub level. And Black Veletopia was actually a very good candidate, because it looked really, really weird and different, right? It had that black velvet painting thing. And that was, in fact, a level that we started on. That was one of the earlier ones that we worked on, and the whole team worked on them. So let's do one more example. For those of you who played Broken Age, like, what would be a good level to start from and why? I don't know if any of you have watched the documentary, but we started working with this level initially. Now, it's a static scene with many characters in it, like the 4 or 5 girls, a bird, a monster, and one of our very first challenges in this game was creating an animation system and experimenting with rigs. It looks like a 2D game, but all the rigs are actually 3D because we wanted to keep the size of the animations quite small. The scene also has a lot of really bizarre sorting challenges. Like for instance, the cake, the bottom of the cake was actually part of the level, and the top of it was part of the character. So like you had to sort correctly and not have any seams when they're moving around. The scene, it gave our tools and process quite a workout as we were trying to figure this out. Especially like in cutscenes, during cutscenes when things actually change and the sorting changes, all of that had to be worked out. Once we figured out the basics, we quickly moved on to a level that would be more typical of the game, where Vala could walk around and do things like that. So this is Mariloft. The flashing, so you saw like how she started to sink like right there. That was going to be kind of a weird, different thing that we had to experiment as well. And there was a lot of pathfinding, so that it might not be obvious, but she is actually doing like A-star pathfinding. And the way that the game was constructed is that there were layers. There were layers for every single thing. So like she had to correctly bridge from one layer to another. Definitely do not pick the first level or the tutorial of the game for this exercise. Like, in fact, you should always make that level last because you'll find that your game will change a lot throughout development. Like, to properly introduce new players to your game, you have to have an intimate understanding of what your game is going to be about, and you're not going to know that when you're first starting out. Like, things will constantly shift for you. Basic braining in Psychonauts, which was supposed to be the tutorial level, it was rebuilt 5 times. Because we made this mistake and we started working on it before we even finalized some of our jump distances. Don't make the same mistake. Another one, cheating is okay. So we as programmers, we have a tendency to over-engineer things sometimes, and I want to caution you to resist this temptation. Sometimes you really don't need to create a super fancy system to get the job done. Like, cheating is totally okay. Like for instance, some of the physics in the cave was substituted with animation. I don't know if you can see this, but that rolling that the barrel is doing, that's animation. Like it's basically just an object sliding. If you do rolling in physics, you might have like these terrible, terrible edge cases where like all of a sudden the player can't solve the puzzle because the physics decided that like an edge is just a little too high for the physics system. The thing about animating is that you know exactly how long an animation would take. It's like a fixed time. So you can save that debugging time for like, that bug will just keep coming up. You can save the time by just making the physics do the simple thing instead. Other places where it's recommended to cut corners or try to avoid altogether is for when characters have to interact with an object. So it is notoriously one of the most difficult things to do well. That is like to have a character perfectly grab an object dynamically. The player is probably not going to appreciate all the hard work and animation you put into this. Although as a programmer, I marvel at how easy Chris Hecker makes this look in Spy Party. Actually, like I was on the IGF jury the year that he submitted this game, and we were asking him, like, so what do you think is the most special thing that you had in the game? Like, what was the biggest programming challenge? And he wrote like an essay about how difficult this was. So just avoid it. The best thing to do is you can use camera cuts to hide all the object alignment problems. The example you're seeing here is from Psychonauts and Black Velvetopia, where putting a painting on the wall actually transforms the level geometry after a cutscene plays. And when the player walks up to that interaction spot, they hit the button, the cutscene would immediately start, and the script would set the world geometry correctly at the end. So it's a cheat, but it works. Another approach that we used in Broken Age was to set up use points for any objects or characters you might interact with. So those are like the little green X's that you see there. That's the position where Vala would walk up. And the player, so it would trigger the cutscene as soon as like that spot was walked up to, in case you needed to do any kind of object switching. If you're low on a particular resource on your team, there may be ways around it without actually cutting the content. So to give you some examples, on Psychonauts, our animators were totally slammed on all these pre-rendered cutscenes in the game. So they were all actually rendered in Maya and then converted into Bink files, if this means anything to you, which could be played in the games. And you can actually really clearly see the difference between them if you play the PC version, because everything is like up-resed except for these cutscenes. Early on in development, the LiPo engine didn't have any cutscene tools, and the runtime cutscenes had to be done in code by gameplay programmers. So let me play you an example of a runtime cutscene I made when I first started, and then show you the code for it.
Huh? Who are you working for?
What? I'm with the Psychonauts.
The who? Oh, that doesn't fit in. That doesn't fit in at all. Maybe I've got this all wrong. Okay, but...
So thanks to the animation library our animators set up, we were able to do quite a bit. There were talk and gesture animations, as well as some very expressive blend shapes that we could use. So like that's basically the whole cutscene that was programmed in there. Eventually, we did develop a visual tool to help us with runtime cutscenes. However, some of those cutscenes, like they shipped in the script, just like you saw in the previous slide. Characters are some of the most time-consuming things to create for a game. And Waterloo World, at the lowest scale, there was dialogue written so that Raz could talk to the occupant of each and every house. So it would have been a real shame to cut that dialogue. And like I said, like it takes a really, really long time and a lot of work to create characters. So I pitched the idea of creating like really simple door animations. So like the door would actually just move as if someone was like talking behind it. And this was something really quick for animators to do and allowed us to keep the dialogue in the game. So here's how that looked.
Hello, I'm recruiting for the army of Fred Bonaparte, and...
Go away! Fred Bonaparte has forgotten the people, and we have forgotten him!
What? Fred loves the people. He was just telling me that some of his best friends are, the people.
He has abandoned us. He doesn't care if we live or die.
Look, I'll tell you what. I'll talk to Fred. I'll talk to him, and I'll prove to you that he cares about the common man, and that the fight is not meaningless.
I'll believe it when I hear it from him.
So you get the idea, like we didn't have to animate anything besides the doors. I want to caution you about where you should not be cutting corners. Everything in your game needs to have a sense of purpose. So for instance, do not cut corners when adding characters to the world in a way that makes them feel like mannequins, like they're just like uncanny valley imposters. I've seen this in many open world AAA games where the characters just stand around like playing like a breathe pose like this. And they were just placed there, and like probably the designer figured like, oh, I'll come back to it, or someone will see this and fix it, but they were just never revisited. And I don't want to pick on any particular games, but you know, we've all seen it. All characters that really need to seem alive is a variety of idols that are relevant to their context, like simple patrol behaviors if you have the luxury, and lines that don't repeat constantly if they're voiced. It really matters to project to the player that there is depth in your world that you've created beyond what the player directly sees. And it's our job as game developers to succeed at this trick, right? It's all smoke and mirrors, but we gotta do that. Over the last 15 years, all kinds of new input devices became available to the games medium, and I think within our lifetimes we'll probably see many more. And I wanted to share you some lessons I learned from making games for augmented reality and virtual reality. So when designing for a new input device, know that you may need to readjust altogether the assumptions that you have about making games. So the expectations that you might have for what will be like interesting and fun, like they will be completely wrong sometimes, and that's really surprising. So case in point, the Kinect. I want to play you a trailer of Double Fine Happy Action Theater and its sequel, Kinect Party. So the game, as you saw, was like a kind of a collection of fun augmented reality activities, like each lasting about a minute or so before cycling to the next one. So I didn't work on this game, but I think it was probably the best use of Kinect because it's kind of like toy-like activities, which it doesn't have any challenging feats or puzzles. So why was this such a good fit for Kinect? So before I get into the design aspects, I want to mention latency. All input devices have inherent latency. What you see there are measurements done by displaylag.com for latency in the dashboard using a controller on PS4 and Xbox One. They're very comparable, PS4 at 76 milliseconds and Xbox One at 87 milliseconds. Games tend to have a bit more lag than that, but it's hardly noticeable for the most part. There's additional lag associated with televisions. The lowest lag measured by displaylag.com is around 9 milliseconds, and the highest is at about 112 milliseconds. So on average, the perceptible lag for current generation console games played on the TV using a controller is between 100 and 200 milliseconds. The Kinect also has lag, but contrary to perception, it is actually not much different from controllers. Like, depending on whom you ask and how you process your skeleton data or whether you do any of that. But here's the problem. Recognizing a gesture takes time. So for instance, let's say you're trying to wake up your system. Like, you can just press like the button right there, like the middle button on a controller. It will register within that 800 to 200 millisecond lag time. And you can have the player, or you could have the player perform a gesture. And it takes time to do a full arm motion. It might take a second or two to perform, even like in perfect conditions, right? So the conditions might not be perfect. Maybe your arm like leaves the camera or something like that. There may just be weird interference, like you have like a speaker right there where your hand goes. Maybe the gesture library that your game is using is not perfectly tuned to recognize the gesture. Maybe you're like a little kid or like a woman, because Kinect early on was not great for like recognizing the female form, or like, you know, just here's an interesting thing. When you hit a button, you have tactile feedback that you have succeeded it, and the rest is left up to the hardware. The hardware sends a signal to the game gets the signal and responds. When you're doing a gesture, the player doesn't know, that they don't have that like full button press in as they're doing this, right? So the player doesn't know whether they've done it yet. The game needs to wait a little bit in order to like succeed in recognizing what this is, and only then will the latency like of that 80 to 200 actually affect how it is. Like, it can feel like it takes like seconds. It's just incredibly, incredibly slow. So the best way to combat this is to provide feedback on the screen as soon as any input is entered at all. So this will allow you to bring down some of the perceived lag to where it would be on the controller. So what you're seeing is an example from our Kinect game, Once Upon a Monster. So even if the player doesn't hit the drum perfectly, as soon as motion is detected, like the hands of Cookie Monster and Grover will animate. Another thing is the traditional design approach is like you make a mechanic fun and then you just add impediments for like an extra challenge, right? So like this did not work well for the Kinect because it's very easy to become exhausted doing this, right? So doing this for 2 minutes straight is actually really physically taxing. So our first instinct when we got the flying levels working was adding things that you bumped into, and like and this was just terrible. So we actually ended up removing all of those obstacles and adding these little like puffs of air that made it easier, like so you could just hold your arms straight instead of like having to do this all the time. So in other words, like it became a carrot rather than a stick. So we rewarded the player for opening the flowers by just going near them instead of blocking stuff. And this is why I think Kinect Party works so well for the Kinect, is because every little activity had something like surprising and fun to play with without pressuring the player to achieve like any particular goal or defeating a challenge. It was just kind of a toy. And right as your enthusiasm for like a particular mini game would wane, it would just switch you to one of the many, many other ones. And it just kind of played to the strengths of AR. Similarly, for VR games, there are things that work incredibly well and some that don't. So I want to show you a couple of examples from Psychonauts and the Rhombus of Ruin. I think everyone who's tried VR by now knows that moving and strafing, especially like with head bob, is going to be like vomit-inducing. So In Rhombus of Ruin, the team followed what some other developers have done and implemented spatial movement through quick teleportations. And it's fairly easy. It's a fairly easy thing to contextualize in Psychonauts. Because Raz has psychic powers, and so seeing things from another person's perspective like kind of naturally fits thematically, and it sells the idea that the player is like this powerful psychic. One of the most satisfying things to do in the game is, for me, levitating objects and manipulating them in midair, because it's like kind of hard to convey this with a video, but it is like you really feel like you have magical powers or something. It's kind of exhilarating in VR. And you're not going to know that until you try it out, because I couldn't have known in 2D that this would be cool. Another thing we found that really surprised us is that having a character look directly at you while speaking to you in VR, it makes them feel much more real, like they're actually talking to you, as opposed to like Raz or some character you're imagining yourself to be. And you end up feeling a connection to them as if like, yeah, they were speaking to you in person.
Mia.
Hello, darling. I just wanted to make sure that you were okay.
Yeah, I'm fine.
And that you knew you were talking out loud.
You could hear me?
Just that last part, about Lily. It's adorable, but we're trying to contact headquarters up here, and it's a little distracting.
Gotcha. So embarrassing.
You can draw a lot of inspiration from culture outside of games to help you with this stuff, to help you like figure out what could be cool in new tech. We as game developers, we tend to kind of iterate and improve on existing ideas more often than trying new ones, but that's really going to disadvantage us with new tech. And it can enrich any game you're working on if you draw influences from things that are external to games. What you're seeing there are scenes from films that inspired Headlander, and Lee Petty, who was the creative director on that project, he would show us these throughout the production at lunchtime, and it actually had like a huge effect on everyone who worked at the team. Like it helped us like set the tone and atmosphere of Headlander, and not just visually, but also for like level and puzzle and character design and writing and so on. So I also just recommend, like while you're in school, like you're not going to get this opportunity later in life. Trust me on this one. Like do as much outside of games or outside of your immediate thing that you think you're gonna work in while you're here, because this is the time where you can experience these things and like feel, like take in all of these influences as much as you can, because it really will help you in your future career. Here's a trailer, by the way, for Headlander that shows some of the more tongue-in-cheek influences those films had on the game.
It is the future. The Everwar is a distant memory. It is a life of automation and pleasure amongst the stars. Welcome to your Topia. Humanity now lives in perfect robotic bodies. They are immortal, free from worry, free from disease, but they are not free at all. This fantastic future world is ruled by an advanced artificial intelligence known as Methuselah. No one knows what it wants or why it has enslaved humanity. But this prison of plastic and fiberglass is about to change forever. Headlander. The last flesh and blood person has just been revived. But they're just ahead, living in a helmet that is a scientific miracle. With this helmet, our hero can thrust through the air, remove those pesky heads, and dock into their neck holes and take the wheel. Headlander. But Methuselah wants them at any cost. And with an army of soulless automatons, equipped with the latest in laser technology, what chance does our hero have? But with help from Earl, a friendly voice in the helmet radio, and Crystal 9 and her group of rebel soldiers, it's going to be one hell of a fight. The ultimate head trip.
to conclude by talking a little bit about where I see games going in the future and what I'm really excited about. So one thing I didn't expect when I started out in my career is how different playing games would become for me once I knew how they were made. With some games, flaws that I could easily ignore before it would become really noticeable now, right? So with others, the magic disappeared because I just knew how the trick was done. And these days, I'm most excited, most interested by experimental and weird games that take maybe a human experience and express it such that they capture the essence of that experience or reflect on it in an interesting, original way. So in other words, games that surprise and challenge your ideas about what games can do. This is like, yeah, I really looking forward to this one. I'll just let this play out. There you go. Okay, so ideally, I want to get surprised by the games that I myself am making. But I'll be honest with you, I have never actually played a game I worked on after its development. In part, this is because I just tend to see bugs and it kind of bums me out. But the main reason is that I already know everything that will happen, right? And the only exception is this guy, Boyd Cooper. So Boyd, the character, he's an inmate of the insane asylum you get to travel to in the course of Psychonauts. He's paranoid, he's fond of conspiracy theories, and he likes to mutter to himself as he tries to kind of put it all together. Tim Schafer wanted Boyd to rant constantly, but have the dialogue be dynamically generated from fragments of sentences so that you could listen to him for a while. And you would never hear the same sentence twice. So what you see there is a document he gave me with fragments of lines, which I was to use to construct his muttering. And so this is what it looked like in the game.
The National Park System in conjunction with the cows. No, wait, I mean, yeah, the tuna canneries. Pretty much control everything.
This is completely, completely generated like at runtime. So how is this done? So what you see here is a state machine diagram that describes how to construct his lines. So for example, you'd pick a conspirator.
The manager of that boy band!
Then pick from a list that could link another conspirator.
Made a deal back in '68 with...
And then pick another conspirator.
The dairy industry!
And then maybe there's a victim involved, so you link them in.
To keep down.
Then pick a victim.
All of us.
And then you maybe finish it off with a non sequitur.
Did I just think that? Or did someone make me think it?
Yeah, right. So this is the very first thing I worked on in Psychonauts. So the fact that I could still be excited about seeing this running in the game, that says a lot to me. By the way, someone actually set up a bot on Twitter for Boyd that does something similar. So I know other people were kind of stoked on this stuff too. So where I'm going with all of this is that Boyd was procedural content. What makes him special though is that it was all clearly human created content, right? So there was a human who wrote those lines. And that's why they're so funny and they were acted by a human as well. And also a human designed and implemented the system by which the content would be generated. The result is that I could still be delighted by what he says over a decade later, even when the rest of the game just could not surprise me anymore. Now, of course, procedural content, it's not very new, but what is new is the way in which you can now create procedural content in games using human-authored elements, which is probably not how most people talk about machine learning these days. Machine learning as a game design and gameplay tool is where I think games will go in the future. Because it allows the developer to focus on interesting aspects of game creation more. So what the heck is machine learning? Machine learning is detecting and extrapolating patterns. That is the simplest possible definition. That's basically all it is, right? So the simplest analogy is the language learning system, program, Rosetta Stone. Do you guys know what that is? Show of hands. Have you heard of Rosetta Stone? Okay, some of you maybe. It looks like this. So usually when you're training a machine, you're using what is called supervised learning. Something like 70% of machine learning or training is done this way. So what you're doing is you're presenting the machine with human annotated data and telling it, for instance, this is a dog, this is not a dog. For those of you who have seen that episode of Silicon Valley where they talk about hot dog, not hot dog, that's basically what it is. The machine then builds a mathematical model that allows it to detect a dog very quickly. So it takes millions of data points to properly train a machine. But once it's trained, it's actually most of the time better than humans at detecting dogs. They've actually done a study on this. There are other types of machine learning too. There's unsupervised, reinforcement, and some other ones there in between. Supervised learning is the most common though. Machine learning is a subset of AI. So it's a tool for AI to be able to make better decisions and to do so faster. So there's been a lot of research that you've probably have heard about into using machine learning with games, but so far it's been almost entirely about the AI player. And I believe that this takes the concept way too literally. But what if we thought of the AI as the entire game itself? Then ML could be used to make the player feel like the game actually deeply understands them and reacts to each player in a unique way. So if this sounds cool to you, I recommend as a starting point using existing pre-trained models, right? Ones that you don't have to train yourself, and seeing what they could help you do in your game. So ML research generally falls into 3 categories. First one, natural language. Now this is things like semantic understanding, sentiment analysis, like knowing whether a phrase is negative or positive. It is used in speech to text, in generating sentences, and so on. Second category of ML models are the visual models. And that's stuff like recognizing objects, segmentation, which is understanding where objects begin and the other end. And this is one of my favorites, is synthesizing images in videos. I'm just going to let this play for a little bit because it's kind of amazing, right? And kind of creepy as well. But kind of amazing. And finally, the last category I'll mention is audio models, and that is understanding what the sound actually contains when hearing a sound, and then also creating sound, synthesizing sound. Many text-to-speech systems use ML. A good resource to check out is Google Cloud's API, which has a natural language sandbox right there that you can play with. As an example of what could be exciting about using natural language ML is the ability to gain insight into something the player just said or typed. So your game could respond to the player in a way that feels appropriate to the emotional tone of what the player said. So for instance, hey, you're stupid, or just kidding, you're great. You can serve up different content based on this. And this is something that your game just kind of figures out on its own. You don't have to pre-program all of those things. A fantastic resource for getting ML into your game is TensorFlow. It's a framework to build and deploy machine learning models. There are resources online for how you can get it integrated with Unity and Unreal. So see if you can integrate it with your game and just start experimenting with the models that have been published, which are mostly on TensorFlow Hub. So that's tfhub.dev. So some favorites of mine are the language-based models. They're part of the Universal Sentence Encoder, and you can find this on TensorFlow Hub. It can do a number of things. So for instance, it can do classification, and that lets you train a model to recognize phrases that are relevant to your game and then ask how well the user input matches it. So for instance, you could teach it what a question is, and then when the player types something in, you can ask hey, was that a question? Just a simple example. You could train it to do much more exciting things than that. Semantic similarity allows you to give a score based on how similar user input is to some of your pre-authored sentences. So what these models do is allow you to remix your pre-authored dialogue lines or other content and present it to the player as a reaction to what the player just said or typed. So where could you use something like this? Have you guys played any text adventures? Show of hands. Okay, actually quite a number of you. So in text adventures, it's interactive fiction games where the player can just freely type things. And normally, a game developer has to program in every single word that the player could possibly say and make connections with the things that they could respond with. And if the developer wasn't thorough enough, the player would get these terrible errors that the word wasn't recognized. So these models are great for when you haven't fully accounted for every single thing that the player might try to do or say. And the machine model can choose the most appropriate line out of the ones you do have in the game and play it as a response. So you can make a game like Scribblenauts without having to write a parser for all the things the player could say. You can also do some really powerful stuff if you can turn the player actions into English language and send those to the model. So sports games do this all the time for commentary. So here's a little example.
Just over 3 minutes have elapsed here in the first. Still scoreless. Puck dropped in the logjam, and the winger reached in and got it. The Sharks skated up on the side. Angles it ahead to Cogliano. Now it's directed to Silverberg. Good save. It's going to have to be something tougher than that to score.
So, you know, the commentary, basically the narrator is saying exactly what is happening in the game. Now, the potential for machine learning, hold on a second, sorry, I forgot to mention, like, I'm not sure if they actually, this is how they did the, you know, whether they used ML for this at all, but it could be a really interesting approach for doing commentary. And the potential for machine learning with respect to game design is just like, it's staggering. Like, so much is possible and so little has been experimented with so far because it's really new. So if you want to get in on the ground floor with this and get like super famous, you know, like now's a really good time to do this. Okay, for my next thing, I want to answer some of the questions that Anna-Kaisa has sent me. So here's the first one. Tell us about your childhood in Russia. How did you get into programming? So I'm actually originally from the USSR, where I grew up until I was about 10. But I lived in Kiev, Ukraine, actually. And this is what Ukraine looked like back then. My dad was really into card games, and he taught me many of them as a kid. And I came to really appreciate like what an amazing tool for game design regular deck of cards was. Like, I'd spend like evenings, you know, trying to come up with my own games to test out with my dad. I also had one of these machines, which is as close to a video game experience as I could get when I was a kid. Outside of the arcade, of course, so we had one at the zoo, and this is like kind of what it looked like. A lot of these games are actually mechanical, not video games. Growing up, my parents often had dinner parties with their friends who would bring over their kids, and since I was the oldest, it would fall to me to entertain them all. That's me right there in the second person. And there weren't, you know, too many board games or toy options for us in the USSR. We had stick to play with, so I would make up games for all of us to play. Much of at the time, like, the games wouldn't really be like mechanics driven necessarily, like a game of tag or something. They would involve more like play acting, like pretending, you know, improvising. And I remember like finding it totally exhilarating when the kids playing like, you know, these games that I made up, like they'd start to come up with original ideas within that world. And it was as if like this made up universe suddenly came to life, like for all of us. And I thought that was just like the best feeling in the world. In 1989, we moved to the United States, and I got to try out Super Mario Brothers on the Nintendo and was just completely blown away. So here was someone who made up a world for other people to play with, kind of like, you know, as we did as kids, and to explore it. But he didn't actually have to be there at all for others to experience it. Like, the game itself was just someone's realized fantasy. It's like he took a little bit of his, like, you know, head and heart and like just put it in front of somebody into this game. And it really opened my eyes to what was possible with video games, and I wanted to be part of the process of creating worlds like that. So I figured that I had to become an engineer. There's very little information about how to get into the games industry, and it seemed like engineers were the people who made games. So when I went to college, I majored in computer science. So what would you want to learn if you were still doing your studies? I would study visual design, drawing, animation, and the basics of architecture. So if I had a time machine, I'd send myself these gifts. Do you guys know about this book? Yeah, that's a pretty famous one, right? So it's still the best book about design if you can only read just one. For architecture, I really like this concise book that I can always just have at hand and consult whenever like I feel stuck with a problem that has to do with level layout in the game. Each page just has like little like, you know, rules and lessons and suggestions for how to think about space. What parts of the game did you work on, and how big were the teams? So this is for like presumably all the games that I made. So on Psychonauts, I was on the level Basic Braining, Milkman Conspiracy, Black Velvet, Camp. The ones that I owned were Basic Braining, Milkman, and Camp. And I did a lot of character interactions, the dialogue system, a lot of the logic scripting and stuff like that, and we also all got to design stuff on the game. Brutal Legend, I was an AI programmer, and then also I owned a lot of the campaign, especially the early stuff. Like I was in charge of that demo that was out for Brutal Legend. There's a lot of stuff that I did over 4 years, but basically like all of the AI stuff was something I worked on, except for pathfinding. I did not work on that. So Costume Quest, I was the lead gameplay programmer. I did all of the overworld stuff in the game. It was a very small team, so we kind of had to do quite a bit, each one of us. Once Upon a Monster, I did a lot of the gesture library stuff in it. I was in charge of several different chapters, and I got to design and actually like voice act in the game. Like there's a flower level where I sing, well, like I actually sing a song and like play one of the flowers. The Cave, I wasn't on the Cave for very long. It was only a couple of months before I switched over to Broken Age, but I did the adventure level, the science level, and the night level, the alpha gameplay for it. Broken Age, I was the lead gameplay programmer. I did quite a bit. Dear Leader, I was a programmer and also team lead. Psychonauts and Rhombus of Ruin, very, very brief involvement. I just did a dialogue system for them. I did a port. Headlander, I did all of their UI. Like we had to actually write it from scratch because Buddha Engine didn't have a UI system. I also, like my proudest moment in that game was I animated the logo. Psychonauts 2, I did a lot of the AI in combat and setting up like some of the damage systems and how to pass messaging in the game and do reactions properly. What games or movies were the inspiration for Dear Leader? So the pitch for the game actually answers a lot of this, and it's short, so I'm going to just play it for you.
In Dear Leader, you play a despotic ruler of a republic just emerged from revolution. The game will have you making decisions to industrialize, censor the press, execute ministers you mistrust, and of course, see to you and yours. It's a political satire inspired by Dr. Strangelove, games like Papers, Please and Cart Life, and the visual style of early Soviet propaganda. The story of your republic will emerge based on the decisions you make. And remember, you cannot make a revolution with silk gloves.
I want to also give a shout out to this game. This is a really, really incredible game from 1992 that was a huge inspiration as well, Floor 13. By the way, this is what the game looked like after about 2 weeks, just so like you can kind of quickly check it out. That's the Papers, Please influence. Yeah, so why was a finished version of Dear Leader never made? So it was never made because unfortunately it's hard for publishers to take on the risk of a political game. There were actually interested publishers after Amnesia Fortnite 2014, but all of them wanted the politics removed. It's a shame because politics are very topical these days. It would have been cool. With what do you start a game project, a Double Fine? And do you start with the game engine or with the story and characters? So I guess the shortest answer is with the story and characters. The longer answer is usually Tim starts with an idea for a world and some characters in it, and then he pitches his idea to artists, and they do an art jam in the studio. This is just to get as many rough sketches and ideas as possible. And the focus here is not on like, perfect or gorgeous art that you'd want to put in an art book, but just on generating as many cool ideas as possible inspired by Tim's description. And then Tim looks at these sketches and maybe like gets excited about them and comes up with like new story and tells the artist to go deeper on a particular sketch or something like that. It's like a self-perpetuating brainstorm cycle. So sometimes this process is very quick and sometimes it lasts a week or longer. Then back in the day, you had to actually make pitches for publishers or even for internal teams. So this is the pitch video that Tim played for us for Brutal Legend. Oops, sorry. This takes a while to go. How do you decide on a game theme as a team, and how are stories created and edited throughout the game dev process? So a Double Fine, usually you have a creative lead who's the vision holder for a project, and that person decides on the theme, and everyone else has a chance, of course, to contribute to the theme, like during brainstorming and throughout the development and so on. As game development progresses, you end up making changes to the story that like kind of suits the game. So sometimes the story has to change because the gameplay went into a different direction. Most of the time, you actually make cuts because the story is too long or elaborate, and there are more concise and better ways to tell it. Like when I know Pixar, when they do stories, like they change so much after just like viewing it a few times. So like this is very, very common even in film, but in games, because like, sometimes technical constraints are there, like it forces you to change things in the story as well. So yeah, the story and gameplay have to be suited to one another, else it just doesn't work. So it's like a perpetual, balancing process. In games like Psychonauts and Brutal Legend, what requires the most effort in terms of skill and work hours? So as I mentioned, both of those games required engines to be built from scratch. So that is probably the most effortful and time-consuming thing. This was a time before free engines that you could just adapt, like Unity and Unreal. So writing your own engine, it's a massive challenge. Have any of you actually done an engine from scratch before? No? Okay. Yeah, it's not recommended. It's really hard. So for Psychonauts, 3D platformers were still very, very new, and there was no consensus on how to make one or even where to start. So we had never made a game as a team, period. So like, by the way, here's something really, really interesting that I kind of just learned over time, is that even if you have a team full of extremely, extremely talented and like, experienced game developers, it doesn't always gel. Like you still need like to actually make something together for your dynamics to like start working and for you to like be able to be productive together. So Psychonauts was like, it had a lot of these growing pains as well. The physics and camera for the game were probably the trickiest challenges, but they impacted just about everyone in the team. Like for instance, like you have jump distances that would affect like how the level is built. The character interactions, because it used the physics system, everything just touched everything else. So we had to write an engine for Brutal Legend as well. This game was even more challenging because it was a multiplayer strategy game. So AI had to be quite a bit more sophisticated than it was on Psychonauts, which is a big challenge for me. It also had an extensive open world single player campaign. So sometimes working in the single player required us to change things on the player, and that impacted absolutely everything in the multiplayer. Everything had to be rebalanced quite often. It had to run on an Xbox 360 with no hard disk. So this is an open world. So like, I don't know if you guys have worked on an open world game, but one of the challenges you have is that you're streaming in everything consistently. You can't have everything loaded at the same time. That would just be, it's impossible, certainly on that hardware. So what you had to do was you had to organize everything on the disk so that tiles, which is how the world was broken up, tiles had to be physically present on the disk next to the other tiles, so that when you're like doing a disk access, that you're pulling in all of the things that are nearby. Otherwise, what would happen is like the disk access read, like for when you're loading things into memory, it would make things like stutter and like just not like stream in time and things like that. That was quite hard. It also had to run on a PS3, and one thing I have to mention is that first of all, the PS3 was incredibly difficult to develop for in the beginning, because Sony just kind of like shipped everything and like wanted the developers to sort of take advantage and figure it all out. But the problem is that the unit was shipped so early that the dev kit, the amount of memory on each SPU was exactly the same as it was on the shipping hardware. And so if you had a problem on one of the SPUs, like for instance out of memory or something like that, buffer overrun, it would crash. The game would crash, and you would have no memory to store any of that information. So that was just extremely challenging. And we got the game running on Xbox 360 very quickly, and it took like a year for the PS3 to reach parity. And then of course eventually it looked a lot better on the PS3. But it was tough. It was not easy. And this was a company that had only shipped the game on Xbox. Like someone else had actually ported Psychonauts to the PS2, which is why it looks so different. What is the most common challenge gameplay programmers encounter in their work? I'd say the most common challenge is how to realize the idea that the designer has, and then to play test it with players who might be really confused by temporary art. So like when you're first trying an idea, like things look really ugly and bad. And the challenge is to figure out exactly how much polish, what is that sweet spot where like the feature can really like be, it's clear what's happening, enough to make a decision about like whether this lives or dies, right? So often even designers aren't able to really make a decision on a feature unless it's like pretty far along, even like final art in some cases. And it's really difficult to get a sense of how something will feel to a player. You have to just hone that sense in yourself to be able to tell that something will work even when it's like completely like super ugly and rough. What is the most recent thing that you have learned about programming? I would say that you have to remain humble and that it is impossible to know everything. Languages and architectures, they come and go. So just when you think you're like, you really got it, like you have it, like you're just such an expert, like you get used to working at a certain speed and then like a new technology comes along and it just wipes you. It just throws you on your butt and like basically it's the process of having to go back to square one every time a new system is released. Anytime you're working a new engine, things can be really, really substantially different. And like you have to retain that balance of humility and confidence and understand that you're going to feel like you're going to continue feeling like you have to learn everything over again, like completely from scratch every few years. But like it's part of the job basically. And this goes for programming. This goes for any kind of game development. Are there major differences programming for two different genres like Brutal Legend and Broken Age? Like, yes, definitely. Well, the technology was quite different for Brutal Legend, like the console situation. Let's see. I kind of went over some of the like really tricky things in Brutal Legend just now. For Broken Age, it had to ship on something like 11 different platforms. And the team on Broken Age compared to the team we had on Brutal Legend was like minuscule. Like I think when we shipped the game, there were 3 programmers. Whereas on Brutal Legend, we had a team of something like 20 programmers. So it was like making it feel like this game was made by a massive team when there were only like 3 of us, basically. And this actually segues really nicely to the next question. What were the programming challenges on Broken Age and specifically? So like I was saying, we had to write tools from scratch on Broken Age. Like we started with Moai, but it didn't have a lot of features we needed to have, and we had to refactor quite a bit of the engine. So much so that I would consider it a completely different engine from what we started from. So we had a visual editor. This is not something that came with Moai. We wrote that ourselves. We actually had to substantially modify our existing tools like the cutscene editor in order to make it work with the game to create our cutscenes. There were a lot of localization challenges. Like I wrote a debug feature that uses the longest possible string in any language, just to find the bugs without having to play test them in each language separately. Yeah, let's see if is it working? Yeah. So all of those should be in different languages. You also need to make sure the game knows how to look up the appropriate texture at runtime. And there's this is just kind of its own talk. Actually, if you want to watch, there's a documentary about all of this. There's there was a graphics programmer working on this. You can see the reflection on the floor. All of this was technology. There's dynamic lighting actually, which is hard to tell, but it makes a difference in a lot of these scenes. We had to do two languages in the audio, and then 5 or 6 in text. We had a Dropbox-based save system that was kind of challenging. We had various exceptions to the rule of the classic graphic adventure. It also had to ship on Ouya, PC, Mac, Linux, PS4, PS Vita, iPad, iPhone, most Android tablets, NVIDIA Shield, and most Android phones. So the interface differences on these are quite substantial, and each platform demanded to be supported on its own terms. So for instance, on an iPad, you have certain expectations for how you want to interact with the game. On an iPhone, your screen real estate is so small that you have to make changes to how things are displayed so that it's still usable. You have to make an offset for the thumb and things like that when you're dragging things around. You had to change how you do the hint system because you no longer have this mouse cursor that you can just scroll across the screen. For PS4 and Vita, you had to you had to use the inventory system in a way that was like, that made sense for console users, like which was on a button and then you could scroll through it. That is not how it worked on the iPad or anything like that. There's also like, you know, how do you very quickly like switch what you were selecting? That all had to be made specifically for each platform. There are also hardware constraints, like the Ouya supported only 2 gigabytes of a game and the game was 4 gigs, so we had to figure out how we were going to do that. The PS Vita has really, really slow I/O, so loading a level just took like something like 30 seconds. We had to fix that. The Android tablets and Android phones, because of there being no standards on images, you had to actually account for 4 different types of image resolution. Now, all of this stuff is you probably can take for granted if you use something like Unity or Unreal, but when you're writing your own engine, you have to do all of this yourself. And this also includes like controller inputs, like really like things that you can take for granted most of the time we had to do by hand. I think it has since also shipped on Apple TV, Xbox One, and Switch, and maybe like others I'm forgetting. There's a certification process for all of these. We also devoted time to support gaze, which allows people with disabilities to play the game. And there were like many crazy peripheral devices that people wanted to play the game with, and like we supported all of those too. We're often asked why we didn't just use Unity for Broken Age, and the reason is that in 2012, when we promised that we would ship the game on Linux, Unity did not support Linux. Moai maybe didn't either, but at least we'd have like, you know, the source code, so we knew that we could at least make it work. So that's what we went with. I'm going to show you an excerpt from my dialogue talk to answer this question, which is how do you design program branching story and dialogue options? So this is from Broken Age. Think of each dialogue choice that you see there as a node, and each level of depth in the dialogue tree as a collection of nodes. You see, so those are all different nodes and things. So here's what a single dialogue tree node looked like under the hood. Each dialogue choice, it has a display line code associated with it. Remember the line code thing? Like that's what it actually looks like. So a reaction to play when it gets chosen, which is usually just a bunch of dialogue, and a bunch of logic that defines whether this dialogue option should appear or not. In Broken Age, the game state was a collection of various facts about the game, that is, numbers, strings, and booleans that are keyed by a symbolic string. And this enables us to have a simpler way to represent logic in dialogue tree data as a sort of like a scripting shorthand. So whether a dialogue choice appears or not is determined from the following checks. Appears when, so everything on this list has to check out before the node will be shown. Appears when at least one of the things on this list has to be true to show the node. And then you have, similarly, the disappears checks. Disappears when everything on this list has to pass the test before the node will be hidden. And disappears when any, so where even if a single item on this list is true, the node will be hidden. So when picking a node, it can additionally set some logic, which can then be used to turn it on and off. And we found this to be very expressive for dialogue trees. How long is the production cycle of one game? That really, really depends. So when, I kind of went over this a little bit already, but Psychonauts and Brutal Legend took a very, very long time, so about 4.5 years each. And the reason, again, was because we had to write our engines from scratch. All the other games, they took anywhere between like 8 months and 3 years. So 3 years was Broken Age. And that is because, again, we had to write a lot of the engine ourselves and the support for all of the platforms. What is the replay value of story games? So this probably not a whole lot. However, I would say that like when Psychonauts came out, I remember we crunched so hard on the game, and at the time there was no such thing as digital distribution, and the game was in the stores, like I swear to God, for 2.5 weeks, and we thought that was going to be it. Like we thought that is the only time that people had the opportunity to pick up that game. And it was heartbreaking because we just killed ourselves working on that game. But thankfully, because of digital distribution, the game actually it kind of attracted a cult following, and it's weird. Like Double Fine is still selling Psychonauts. Like people still buy it. So I guess my answer to this is that I think it's important to strive to make the game that you want to make. and that the replay value is something you should definitely consider. But ultimately, if you are struggling, like, oh, I really want to make this game, but no replay value, like maybe you should still just make the game you want to make. But that's everyone is different. I just think that sometimes replays and stuff like that and the support for the game can really surprise you. So how does the cooperation work between designers and gameplay programmers at Double Fine? So back in the day, I would say that it was just basically like a couple of designers, and the way that they designed was very, very sort of broad and high level, and that gameplay programmers were in a position to really fill in the gaps of that design. So that's how it kind of worked. And then we would present our efforts to the designers, and we would for instance, they would tell us what the idea is, and it's like, okay, that's the idea here. And that's what you kind of always so you work here and you compare what's actually in the game to what the designer had wanted. Sometimes you need to make compromises, but you always have to make sure that the designer was cool with that. Or maybe sometimes you actually come up with something even better than what the designer had thought was possible, because you know how the engine is, and you know some deep insights that make something really cool really easy to do. So that's the collaboration. But I think it's different now because they actually have quite a few more designers. So I think the gameplay programmers, also with the advent of Unreal, are more in a tool support role. So that's a little bit different. Do artists and programmers work closely together and brainstorm ideas? And can programmers influence the narrative of the game? So this is something that's pretty unique to Double Fine. Everyone just was kind of in the same open space, so everyone worked very closely together. They brainstormed ideas together, it was just everyone was involved. In fact, there was this, what they call the hour of fun, where everyone in the game was forced to play the game. It's a forced hour of fun, but it was still fun. But the point here is that even somebody who is not working directly on the project, somebody who's maybe the office manager, the HR person, if they want to play it and they have a cool idea that they want to contribute, they totally can. That's how it was there. So yeah, the programmers, anyone can influence the narrative of the game. And that's just the kind of culture that Tim sort of fosters at Double Fine. So this might not be the same in all the studios. I might have been living in a bubble all this time, so I don't know. Do I have a funny story? I do, actually. So one of my favorite stories was, so I had this friend, Joe, who had just joined the project on the original Psychonauts. And he was really I think he was working late one night, trying to figure everything out, and everyone had left the office at that time. And he was given the Mila level, Mia, or I think pronounced Mia. And her level was super bright and colorful. It was a dance party. It was based on Groove is in the Heart, Delight, that music video is basically the big inspiration for it. However, Mia, I don't know if you guys know this, but she had a personal demons room where they would whisper things why did you let us die? And the orphans, it's basically because Mia's backstory is that she was a teacher at an orphanage and it burned down, killing all the children, and she felt this incredibly deep regret about it. And this was a weird thing to have in a game, because this was especially in her level where everything was bright and shiny, and this kind of came crashing and it made no sense. But here's the funny thing is that at the time, so when these lines would this terrible whispering would kick in when you're really close to this room. But we had a bug where it didn't actually turn off, and sometimes it would kick in when you were nowhere near this room, and it was 2D audio, and so the audio would play over everything else in the game. And so he was trying to do I think it was this race thing. And so he's doing this race. It's why did you let us die? And he was what the fuck? What is going on? And so he would because he's alone in the office, everything is dark, and he would just pause and walk around. Is anyone here? What's going on? He had no idea. It was just freaked him the hell out. And so he actually went home. And the next day he comes in and he sheepishly asks us hey, so is there creepy whispering in the game, or like, is that like, do you guys know anything about this? Like, what could it be? And we were like, we have no idea. We were like, no. Like, I swear to God, it took us like a day to figure out what he was, what he, like the bug that he came across. That's my story. It's really good. I could not stop laughing. So what's the inspiration behind the original Psychonauts? So the inspiration, and this goes back to the thing I said about how, like, while you're in school right now, you should totally take advantage and take classes that are outside your major, and like just anything that even remotely interests you, because this is like, you can devote your full attention to that class, whatever it was. The inspiration for Psychonauts was a class that Tim took. It was like a dream analysis class or something like the psychology department offered, and it was like, you know, touched on like the, you know, pop psychology concepts and things like that. So, but he was like really fascinated by the idea that you could physically enter the world of your dreams and like walk around, and he would think like, well, what would it be like if I, you know, like, what is that person's inner world? Like, what is their dream like? Because when someone tells you a dream, usually it's the most boring thing in the world, right? But it doesn't have to be. What if like you could actually play, like, you know, run around in it? So that was, I think, like the big inspiration. There's so many origin stories for this, but this is the one he told me at least. Can you tell me more about the upcoming Psychonauts 2? So what I can do is I can show you the new trailer that just got released. It's hot off the presses.
I want to tell you about a boy.
Ooh, is it me?
Please save your questions to the end, Rasputin.
Okay.
He was a uniquely talented acrobat, but also a gifted psychic.
Don't forget my canoeing badge.
He was a big pain in the neck. But somebody messed up and let him into the Psychonauts.
That was you, Agent Cruller.
This 10-year-old circus runaway was somehow allowed to join an international group of psychic super spies. And now he's headed to our main headquarters, right into the Mother Lobe.
Man, you guys really like puns.
But he better wise up. This is no summer camp. The Mother Lobe has its own way of doing things. Its own way of protecting itself from outsiders. Its fair share of dangerous, hidden secrets. If they ever got out, things would never be the same again for the Psychonauts. For your friends. For your family. For you. Listen, Rasputin. There are vaults that should never be opened. Not all minds are safe to read. Some brains are better off broken.
Don't worry. I won't do anything crazy.
Well, whatever you do, just leave me out of it. Ooh, is that honey pepper boar bacon?
And I want to leave you with this video compilation of Double Fine bloopers, which are just bugs that we had in the games, various games. You've seen this one already. And I can leave this up. I want to just open it up to any other questions you guys might have, if you have any.
Is my mic on? Yes, excellent. Thank you, Anna. That was so super exciting. Any questions from the audience? We had a lot of questions at the end, so
yes,
we're
I answered a lot of them.
I do have one, but
yes.
try to think about if you have some questions. There's a mic coming up. So those of us who are not programmers, we oftentimes think that programmers are just, this one role, and they do all the code. You're a gameplay programmer. What are the other programming titles that Double Fine has had throughout your years?
So there usually, like, there's a division between what are called system programmers, and those are people who do things like actually graphics or platform porting or physics systems, or like there's just quite a number of different roles that kind of fall into that. There are people who specialize only in graphics because that's a huge field that you can just like get lost in. Gameplay programming and being like very close to the player experience was something that I was particularly passionate about. But gameplay programming actually also involves sometimes writing animation systems, sometimes like writing camera systems, which at some companies are split more the other way. So I would say like you have system and gameplay that are pretty distinct, but also graphics sometimes like is either part of systems or its own thing.
What do you think? What if you're like a budding programmer? What is the field to go now? Machine learning?
I would say that machine learning, but only okay. So I would say machine learning is important for you to know now because that's the new that's the interesting thing that could really make games super even way more reactive to the player than games are able to do now. And it also is one of these things that allows you to focus on a whole new higher order level of problems compared to like what we're focused right now. A lot of my work as a gameplay programmer had to do with like cooking up all of these logic components that ML can actually very easily take over, and I can focus on writing like it frees me up to do way more weird and interesting stuff, at least as a gameplay programmer. So I would recommend that for any of those, but especially for gameplay, it's very useful. Personally, like I think you should know a lot about all aspects of the engine, but also a little bit about the disciplines you would expect to work with. So for instance, if you're a gameplay programmer, you need to know a lot about design, and you need to know a lot about space creation and also animation, because those are the teams that you're going to be working with a lot. The level designers, the 3D artists, and the animators.
And there's a lot to learn.
Yeah, there's a lot. It's a ton. But
trust me, you can also easily get into game programming by not being a programmer. So I've made games with the tools like you mentioned in the early of the lecture. Exactly. Any questions? Yeah. Wait for the mic. Can we get the mic into the front? It's a throwing mic, so maybe. Yay! Good.
Okay. Do you enjoy the games as much as you used to before becoming a gameplay programmer?
So like I mentioned, not exactly. And so basically once you know how the trick is done, there are games that there's like a whole category of games that I no longer enjoy because I just see how like, oh, okay, they did it like this. Like my brain just goes into immediately figuring out how they might have done something. And the things that I enjoy now are games that can take my focus completely away from that. So really weird stuff like Baba Is You, like there's a lot that is exciting to me from the indies because like that's kind of where their mind is. They're trying to do something that hasn't necessarily been done before because they're able to do so at a lower fidelity, which and the reason why big developers don't take as many risks is because it's very expensive. What they do is they try to see what has been like done successfully and to combine the elements from those. So the brand new things are actually coming out from the indie space. And that's what I'm interested in seeing so that I can be like, oh, this worked really well. Let's take like some of the ideas here for our next game. And so as a game developer, like I think that's just where my mind naturally transitions.
To Lasse?
Yeah, I have a quick question about the machine learning things. Do you know any people or projects that are promising in terms of like machine learning and game design? Because I've been thinking about it, but yeah, I haven't seen much.
You're going to be a little bit on your own with this. Like that's the thing, but that's also kind of exciting because like you're going to get so much credit. Like you're going to be the guy who like everyone's like, oh, have you seen this project? Yeah, no, seriously, like you could be that person, but you do have to do the work of actually experimenting with that stuff. And I'll be honest with you, like right now, a lot of the ML stuff, like they're really trying to make it easier for you with like the TensorFlow and like TF Hub and stuff like that. But it can be kind of like really hard just because it's so different from the work you're normally doing. But just like try to look past that and like see the advantages of it. And I think the best is to just try out a model, like try to read like what the description is and like what could maybe be done at runtime with it. By the way, this is a big one, is that sometimes ML models are too slow for runtime, or they can still be used but asynchronously or something like that, where like you just send a wave, like let it work in the background and then eventually it'll return. Like that's still an option, but like the most exciting ones are the ones that are like fast enough that the latency is quite small. So.
Yeah, we have made one prototype. I can maybe talk about it later.
Yeah.
Okay. Well, see, but thanks.
Yeah, I think we're running out of time, so there's plenty of time for us here to discuss more while we do the coffee drinking. I hope that there is a coffee. There's coffee, right? Well, people at home has to cook their own coffees, of course. We have also a special treat for people here, so we have another double finer. So if we want to talk about 3D art, Ebbe Lonborg. Difficult. Lomborg.
Lomborg, yeah.
Okay, so ask about the surname as well.
Yes.
So it's been a great year. Thanks for joining us. Make sure that you follow us on the social media. We have excellent program for the spring. We haven't announced it yet, but there is going to be quantum and death, for instance. So thank you, and let's coffee.
Thanks for coming, guys.
Thank you.